In this video, we take a look at the concept of image formation as well as image formation using mirrors. So first, let's take a look at image formation. Images may be formed when reflected light or refracted light intersect at a particular point. At that point, the image is formed. Now, what is an image? Basically, an image is an optical copy of an object. You have an object, and because of reflected light or because of refracted light, you have an optical copy of the object. That optical copy is the image formed using light and the object. There are two types of images. We have real image and virtual image. When actual reflected light or refracted light intersect, the image that is formed is referred to as a real image. On the other hand, if there is an image that is observed, but at the location of the image there is no actual reflected light or refracted light, there is no actual light at that location of the image is said to be a virtual image. For instance, say you have a reflecting surface, a mirror, you have an object, light from the object is reflected off the mirror, is reflected off the reflecting surface, bounces off the reflecting surface that is, and eventually the light reaches an observer's eyes. The observer sees an image of the object in this location. If you trace back the reflected light intersects at this point. So an image is said to be formed at this point. And indeed, the observer sees the image at this location. But note that the reflected light is here at this point in front of the reflecting surface. But the image is located here behind or even inside the reflecting surface. So there's no actual light here, and yet there is still an image formed here. This is a virtual image. So you have real image and virtual image. Be able to tell one from the other. Now, images may be used or formed rather using what is referred to as mirrors and lenses. We'll take a look at mirrors first. Mirrors are basically reflecting surfaces. Mirrors are optical devices that use reflected light to form images. There are two types of mirrors: flat or plane mirror and spherical or curved mirror. So by their name, you already have an idea on the shape of the mirror. Flat mirror and then curved mirror or spherical mirror. For curved mirror or spherical mirrors, we have two types that we need to consider. We have what is referred to as the concave mirror, also known as converging mirror, and you have the convex mirror, also known as the diverging mirror. And we'll take a look at each one of these: the plane mirror, concave mirror, and convex mirror. Whatever the type of the mirror that you have, so whatever is the type of the mirror, there's only one equation to consider. 1 over S plus 1 over S prime is equal to 1 over F is equal to 2 over r. So F is equal to r over 2. And then we also have M is equal to negative S prime over S is equal to H prime over H. S is referred to as the object distance or location. S is basically the location of the object with respect to the mirror. So what's the distance and location of the mirror, of the object with respect to the mirror? That's S. And S is positive if the object is in front of the mirror. So for the most part, S is positive because because in front of the mirror is where you will usually find the object. But in some instances, somehow the object is behind or inside the mirror. For this case, S is negative. So note distance, we're talking about distance here. So unit is location. So distance or location. So the unit is unit of length, meter, centimeter, and so on. S prime is called the image distance or location. It's the location of the image, whether it's real image or virtual image, the location of the image with respect to the mirror. S prime is positive if the image is in front of the mirror. If S prime is positive, you have a real image. Note, mirror, reflected light is in front of the mirror. If the image is in front of the mirror, therefore the image is formed by actual reflected light. So if S prime is positive, you have real image. On the other hand, if S prime is negative, the image is behind or inside the mirror, you have a virtual image. F is referred to as the focal length of the mirror. It's a property of the mirror. Each mirror has a corresponding value of the focal length. F is positive if the so-called focal point is in front of the mirror. You'll see what we mean by focal point in the next slides. If the focal point is in front of the mirror, F is positive, but if F is negative, the focal point is behind or inside the mirror. R is the radius of curvature of the mirror. We have spherical mirrors or curved mirrors, so there is a curvature to the mirror. The radius of curvature is R. And R is positive if the center point of the curvature is in front of the mirror, and negative if the center point of the curvature is behind or inside the mirror. Now M is equal to negative S prime over S, and so on. M is referred to as the lateral magnification. The image may be larger or smaller than the object. So we have what is called the magnification, and M will be positive or negative depending on H prime. H is object height. What's the actual height of the object? And the H is always positive. H prime is referred to as the image height, and it's always is always in terms of comparison with H. If the orientation of H prime is the same as H prime is positive. The image is erect or upright as compared to the object. On the other hand, H prime is negative if the image is inverted or upside down. So regardless of whether you have a flat mirror, concave mirror, or convex mirror, this equation will apply in terms of the image formation. Now, a plane mirror, as its name suggests, basically a flat reflecting surface. So bear in mind your law of reflection. For a flat surface, the radius of curvature is considered to be infinite. Infinite divided by 2 will give you a focal length of infinite, which means S prime is just equal to S. Going back to our equation, 1 over F, 1 over infinite is 0. Therefore, 1 over S plus 1 over S prime will give you S prime is equal to negative S. Negative, the image is inside the mirror. The image length is opposite in the opposite side as compared to the S. So, object distance, image distance S prime. For a plane mirror, the image height is just the same as the object height, so the magnification is 1. It's always 1. If it's not equal to 1, the magnification is not equal to 1, then you do not have a plane mirror. You might have a curved mirror, either a concave mirror or a convex mirror. Speaking of the concave mirror, sometimes referred to as the converging mirror, the concave mirror is a curved reflecting surface where the center point, so this is our mirror, the center point of the curvature is here in front of the mirror. You have a concave mirror. For a concave mirror, the radius of curvature is positive, which means the focal length is also positive. Focal length tells us the location of the focal point. Focal point, basically, if the concave mirror, if you have a concave mirror, if you have light that is parallel to the center line, that light will be reflected towards the focal point. That's why a concave mirror is also referred to as a converging mirror. There's the tendency of the reflected light to converge at the focal point. And you can use a concave mirror to form an image using the reflected light. Convex mirror, on the other hand, the center point is on the other side. The mirror is curved such that the center point of curvature is behind the mirror. So you have incident light reflecting off the mirror. The center point of curvature is behind the mirror. You have a convex mirror. Since the center point is behind the mirror, radius of curvature is negative. Focal length is also negative. The focal point is behind the mirror. Notice the following. When incident light parallel to the center line strikes the mirror, it is reflected, the tendency is it is reflected away from the focal point. That's why a convex mirror is also referred to as a diverging mirror. So that's it for now. In the next video, we'll continue our discussion on image formation. This time, we'll take a look at image formation using lenses. So thank you for watching.